Alright, are we having fun with these exponent properties yet? What's kind of tricky is all the problems are just a little bit different, so you just have to kind of keep in mind all the stuff we've been doing on the different examples and when we can apply the same ideas again. Alright, so example 17, we have the square root of a fraction. So first thing we would look to see is, can you reduce the fraction? We have x's on the top, y's on the bottom, so we cannot. So what we're going to do now is we're going to break it apart. That's equal to the square root of x squared over the square root of y cubed. Well, the square root of x squared, that's going to be the easier one because we've talked about how the square cancels away the square root, leaving you with just an x. Another way to think about that is, because you're taking a square root, and think of a square root as being the second root, that 2 is an important number. How many groups of 2 can you get out of x squared? Well, you can get one group of 2, which is why it's an x to the first power. Alright, so this y to the third, I'm going to use that same idea. That's y times y times y. We're taking a square root, which is a second root. How many groups of 2 can we get out of y to the third? Well, here's one group, so there's 1, and then I can't get any more groups of 2 out, so I'm going to have a y to the first, and any leftovers stay underneath the square root. So y to the first square root of y. We'll go over that thinking some more, and it's a nice little shortcut, so that's why I'm showing you that. Alright, so what we have is x over y square root of y. Well, how does this look for a final answer? Well, we know we can't have a square root or a radical in the denominator of a fraction, so we're going to rationalize this. We have the square root of y, so we're going to multiply by the square root of y. Now on the top, that leaves us with x square roots of y. On the bottom, this square root of y times square root of y, if we think about it the long way, it's the square root of, you'd multiply the y's and get y squared, and the square root of y squared is just y. So really it's a y times a y. So we just have y squared in the denominator. Even though it looks a little bit messier, mathematically it's a better answer because we do not have a radical in the denominator anymore. Alright, this last example is going to be kind of a mess, so bear with me on this. We have the cube root of a fraction. First thing we notice is inside the fraction there's no reducing that we can do, so now we cube root everything. So we're going to do the cube root of 27a over the cube root of 4b to the fourth. Alright, well, the cube root of 27a, well, we can take the cube root of 27, that's one of our cube root numbers. Can we take the cube root of a? How many groups of 3, because it's a cube root, fit into an a? Well, there aren't enough. You have to have at least 3 a's to cube root it. So what's going to happen on this is we're going to take the cube root of 27 and get 3, but then that a stays underneath the radical because we couldn't do anything with that. Alright, now we have the cube root of 4. Well, can we reduce the cube root of 4? Remember, our cube root numbers are 8, 27, 64, 125. Well, 4 is too small. You can't reduce a cube root of 4. So that cube root of 4 is going to stay. Well, now we have the cube root of b to the fourth. So I'll write this out, b times b times b times b. Because it's a cube root, we want to know how many groups of 3 we can fit. Well, here's a group of 3. So the cube root of b to the third is b. So that b goes out front. How many b's do you have left? Just 1, and that goes underneath the radical with the 4. Alright, are you ready for this to get fun? Now, what do you think about our answer? Well, there's a radical in the denominator, and we cannot have a radical in the denominator. So we have to multiply this by the cube root of something so that our answer is something we can take the cube root of. Alright, so we have to address two things. We have a 4 and we have a b that we're cube rooting. So if you think about our list, 8, 27, 64, does this 4 fit into any of these? And you'd say, well, yeah, it fits into 8. Well, 4 times what number gives us 8? 4 times 2. So we're going to multiply by a cube root of 2. So what I'm going to do here is cube root of 4 times cube root of 2 gives me a cube root of 8. Alright, that's something we'll be able to take the cube root of. Alright, now the trickier part, because we've done that before, now we have b. We have to cube root the b's. Well, how many b's does it take to cube root? You want 3 of them, b to the 3rd power, because the cube root of b cubed is just a b. Well, we have 1. We have 1 right here. So how many more should we multiply with? We need 2 more. So we're going to multiply by a b squared. So b times b squared is b to the 3rd power. Now we have the cube root of 2 things that we can actually take the cube root of. Whew, alright, hopefully you guys followed that. So now I'm just going to get the rest of the problem over here. We have this b out front that just stays out front. We have to multiply all of this together. Well, that 3 is going to stay out front. And then we have the cube root of, and we can go ahead and multiply the a times the 2b squared. And that's just going to be 2ab squared. Alright, so the reason why we had to do all of that was so that we could fix this radical down here. So this cube root of 8b cubed, the cube root of 8 is 2, the cube root of b cubed is b. Bring down your b, so you have a b times 2b, which is 2b squared. And then the top, we have a 3 times the cube root of 2ab squared. Now, should I go ahead and reduce the b squared with the b squared and the 2 with the 2 and just cross those off? Hopefully in your mind you're saying, nope, don't do that, because this is underneath a radical, this is not, so they cannot be reduced together. So that's our final answer.